Many programmers seem to believe that C++ is a superset of C, meaning it shouldn't matter whether you compile a valid C program with a C compiler or a C++ compiler. And today I want to dispel that myth. Okay, so I prepared a little shell script called G, which simply clears the screen, then invokes the C compiler, and then echoes a nice separator to the terminal, and then invokes the C++ compiler with the same program. And here's the first program. Let's immediately compile it in C. So the C compiler is perfectly fine with the program, and the C++ compiler complains on line 2, which is here, and says redefinition of int I on line 1 previously declared here. So you can see we define the same variable twice, and that's illegal in C++, but C allows it, and it's called tentative definitions. Why C allows this, I have no idea, but that's how it is. So that's example 1. Let's go to the next example and immediately compile it. So here you can see a classic for loop that counts from 0 to 9 inclusive. And the interesting part is that inside the for loop, we declare a variable of the same name and type, but that doesn't matter. Again, C is perfectly fine with this program, and C++ complains about a redeclaration. So why is that the case? So in C, the loop counter has its own scope, right? So you can think of the scope, the whole for statement, and then when the block starts, we introduce a second scope or open a second scope. So this I is a different I. In C++, the loop counter doesn't have its own scope, but it's injected into the loop body. So we only have one scope instead of two, and that's why illegal to redefine E inside the same scope. And I only recently discovered this by accident and was very surprised. So that's example 2. Okay, let's look at the next example. That would be C. Again, the C compiler is perfectly happy, and C++ complains. So in line 5, jump to label exit from here, crosses initialization of int I. Okay, so in theory, we could access I down here, and C++ complains that, hey, if you access I in line 6, you would get some undefined garbage value, and I'm not going to allow this. I'm too strict for this. Whereas C says, I don't really care if you want to read garbage from memory. That's your own problem. Okay, so that's example number 3. On to the next one. Let's compile it like this. So here we have a duplicate case label in line 6. We already had the same case label in the line above. So size of jar is defined to always evaluate to 1. So this is case 1. And then character literals have type int in C. So this will give you size of int, which is very likely more than 1. So maybe 2 on very old systems, or 4 or 8 on today's systems. But in C++, character literals have type char, which makes a lot more sense, but which makes this program not compile. Why character literals are of type int in C, I have no idea. Maybe you can let me know in the comments. There's probably a very good reason for that. So that was example number 4. Let's go to the next one. And let's compile. Okay, so what's the problem here? Line 5, that's here. Invalid conversion from void pointer to int pointer. So in C, you can convert void pointers to any other pointer type, and C++ does not allow that. There is no implicit conversion from void pointer to other pointers. So if you wanted that, you would have to write that as a cast here, be it a C cast or some a static cast. I'm not going to show you the C++ solution because you shouldn't use malloc in C++ anyway, right? But you can typically spot C++ programmers when they cast the result of malloc. C programmers never do this because it's too easy to write the wrong type here. So there's really no benefit in C to providing that type information. Okay, so that was example number 5. Let's go to the last one. Okay, so at least in C now we get a warning. It says implicit declaration of function f But that's all. And C++ complains in line 3 that it has no idea what f is supposed to be. So in C, whenever the C compiler encounters something that looks like a function call, but it doesn't know the name of the function, it says, oh, the function will probably be defined later. I guess it takes an arbitrary amount of parameters of any type and it returns an int. And then on line 6, this suspicion is confirmed. Indeed, f takes some parameters, who cares what they are, and it indeed returns an int. And that's legal in C, at least until C99 said, no, I no longer allow this, but GCC still allows that for some reason. Yeah, okay. And of course, in C++, that's not allowed. F could be anything. It could be a user-defined type. This could be a constructor call. We really don't know what's going to happen here, so C++ doesn't allow it. Okay, so let's quickly review all those examples. Here we had the tentative definitions. Here we had the scoping of the for loop counter. Here we had the crossing of the initialization via goto. Here we had the duplicate case because character literals are of type int in C. Here we had the implicit conversion from void pointer to int pointer. And here we had the implicit declaration of the function. So hopefully this is proof enough that C++ is not a superset of C, so there are perfectly valid C programs that will compile with GCC but won't compile with G++. And that's all for today. Bye!